So good morning, class, and welcome back again to our class, to our machine vision in agriculture class. And this is a continuation from the previous class, where the previous class we dealt with reading images. Now in this class we'll read videos, and we'll read videos either if it's a feed from a camera that is connected to our computer, or it's a video file that is in our file system. So we'll use the OpenCV library, and this is a common library that we'll be using even in later in other exercises that we'll be doing. And yeah, so when you're creating videos, one thing you should notice that you need to create the video capture object that should be able to capture the frames. And videos are just a sequence of images, which are normally referred to as video frames. So you need to create an object that can capture the video, the frames, and also use the I'm sure method to display the window that has the frames displayed. And after that, we'll destroy all the windows. So that's what we'll be doing today. We'll start by reading a file that is in a video file that is in our file system. And that's the same method that you use when you want to capture the feed from your web camera, or the camera that is connected on your machine. And this is, you should note that when you want to capture a video that is from your web camera, you have to pass the device index as 0 as an argument to the video capture object. And if there's another camera that is connected to your computer, you need to pass 1, 2, depending on the number of cameras that are connected to your computer. So let's begin. As before, the first thing that you need to do is import the necessary libraries. So we'll begin by importing the libraries. And for our case, we'll import the CV2 module, since we're using the OpenCV library. So let me comment that. It becomes easier for you to follow through when you're doing it on your own. So import the libraries. So import the CV2 module here. Import CV2. That makes us be able to read as well as display the image, the resulting video. And also import NumPy. NumPy also. NP. The next thing that I'll do is create now the video capture object that will be able to capture the frames. So I'll create the video capture object. The video capture object. So let me call the video capture object as, let's assign it as, let's call it cap, and cap equals to use the CV2 and video capture to capture now. And like I said, the video capture object takes in an argument which is either the device index of the camera that is connected to your computer, or the name of the file. So let's read a file that is in our file system first. And the code becomes just different on this line, where if you're reading a camera from a feed, if you're reading the feed from the camera that is on your computer, you will have to assign the device index number here. But if you're reading from a video file that is in your file system, you need to pass the video file name. So let me see if I can get a video here. Yeah, we can get this one, video playback. So I'll pass this name. Yeah. So it's got video playback. And you need to specify the file format. For our case, this is the MP4 file format. Let's see if I got the name correctly. Yeah, video playback MP4. So that's the video file that we're going to display. Now we have already created the video capture object. Now we need to start displaying the frames, which is the whole video, but frame by frame. So I'll use the while loop. And if you remember from your, I think the Python class, you went through this while loop. So that's what we'll be using. So it will check the condition and then break the loop. So let's see which conditions will be checked when you're reading these, when you're reading the images frame by frame. So now we're going to use a method that is called open to check if the camera is opened or if the video file is in our file system. So I'm going to use cap. If cap is opened, if it's true, then it should let us read and display the frames. So I'm going to check that. So if cap is opened, the next thing has to be so if cap is opened, the next thing should be now let me say start displaying the read the frames, read the video frame by frame. So in order to do that, we need to return. It should return true. This will return true and also get another variable to assign the frames. So I'm going to use cap.read to read the frames, and so that will how we'll get the frames, the video frame by frame. So let's check that if it's true now, meaning that if the camera is opened and if the video file is also in our system. So I'm going to use if ret is true, and you should do some other things. So if this is true, I wanted to start use the I'm sure to display the pop-up window with the corresponding video or video feed. So if this is true, the next thing should be using the I'm sure to display the pop-up window. So like what we did with images, but for this case, we're reading from videos. So like before, the I'm sure method gets in, accepts two arguments, the first argument being the name of that window. So I'll assign the name of the window as, let's call it, you can say frame 1 or window 1, whatever you have to call it. And the next argument is the frames that will be read from there. So these are the frames that, so that's the argument that it's going to be displayed. So when you're done with that, now this will display the window, pop-up window. After that, we need to close the window. So you need to press any key on your keyboard to close the window. So let me comment that. Okay. Press, let's go say press Q to quit. Press Q on the keyboard to quit displaying those frames. To quit. So I'm going to use the wait key now. Now this is the part that you need to be careful. So like when you're reading images, we specified, we passed the 0 as the argument when on this wait key function. Now, if you pass 0 now for videos, if you pass 0, meaning that it will display only one frame in an infinite number of time. But in our case, we want to display all the frames that are in that video. So you need to assign a number that is greater than 0. So in our case, let me assign gonna assign any number. Let's just say 25, and I need that when I press Q on the keyboard to quit displaying the window. So I'll use hexadecimal. So like we did, this is just a repetition from what we did in the previous class. So just need it to be specific. Like when I press Q on the keyboard, it should close that window. So yeah. So if this is if this has been pressed on the keyboard, you should break that. So break, and then so if this all has been done, else displaying the window, else you should break. So if it has returned either false or what, if the frame is not displaying you, so you should break. We're going to break the whole loop. After that, we need to release the video capture object. So let me comment that. Release the video capture object. And we'll use the cap.release, we'll use the cap.release like the way we did with images. So this becomes the same as when we did with images. And after that, we need to close all the windows like we did before. So close all the windows that have displaying the frames, close the windows. So we'll use the destroy all windows. So the cv2 dot destroy all windows. So this is easy because this is what we did with images, but now we're reading videos. So the first step is importing all the libraries. This is the end, okay. So the first step is importing all the necessary libraries. After that, you create the video capture object. And if you're reading from the camera that is connected in your PC, you substitute this with the device index number of that camera. And then if you're reading from a video file that is in your file system, you need to specify the name of that file. Then we'll use the while loop to display all the video, the frames in that video, and you can press Q on the keyboard to quit that window. And if the video file is not displaying or there's some error here, it's returning false, you should break that loop and use the release to release the video capture object and close all the windows. So that becomes really easy. So let's run this and see if we can also share the window. So this is the video. Let me so share the screen. Yeah. So this is also so this is the video that we are reading. So if I press Q on the keyboard, it should quit, and yeah. So we can begin sharing again our screen. So that's how you can read a video file, display it, and also I might close the window that is displaying it. So as an exercise, I want you to read, instead of reading a video file that is in your system, you need to read from the camera that is connected on your file system. And this exercise is important because we're going to do the face detection exercise where we'll be reading a video that is on your camera to get the face detection. And also in applications in machine vision, you'll be reading video files, maybe either it's a live feed from a camera on a drone that is flying on your field, or it's just a video file that is saved on your computer. And you either do some object detection on the video, or some segmentation, either semantic or any other pre-processing or any other application. So I need you to do the exercise so that you get familiar with how you can read videos. And yeah, for today, that's the exercise. And one thing I also want to say, with this code that I displayed here, is it will work with Jupyter Notebooks, but with Colab, Google Colab, it won't work unless you include some other either JavaScript, or because Google Colab it's hosted in the server, so it's a remote server, so it can't. With this code, it can't locate the camera that is on your device, on your computer, so it would fail. It will give you an error when you're using Google Colab. So you need to include some other code so that for it to, and we'll see this as when we're reading videos, when you, or when you're working with more examples with videos, and when we use Google Colab. So that's it for today. I want you to do the practice exercise, especially reading from the feed, video from the feed of a camera that is on your machine. So that becomes handy when we are dealing with the next, I think in the next 2 weeks, the exercise of face detection. Yeah, so I welcome again you to the next class, which is, we'll start now pre-processing images, and this will be a good class because that's the part that determines the accuracy of your model. So yeah, so the pre-processing part will be fun. Actually, you'll read more images in a folder, and also get images either from online repository. Welcome again to the next class, and thank you for today. I'll share the code in my GitHub page, and also the video will also be shared. Thank you.